Welcome back. In this video, we're going to graph a piecewise defined function. And what that means is we have a function with three pieces. So I'm underlining them here in blue, red, and purple. And each of these pieces is defined for a specific domain. So these pieces that I've circled here in green, x being less than or equal to -3, x between -3 and 4, or x greater than 4, these are the constraints. Remember, the constraints are the rules. They tell us where we can plug our x values in, right? Where the function is defined. These represent intervals. And they create two boundaries. We're going to have a boundary at x equals -3, as well as a boundary at x equals 4. So I'm going to draw that over here on my graph. Remember, x equals represents a vertical line, so I have an invisible vertical boundary at x equals -3, as well as over here, I'm drawing a dotted line at x equals +4. So you'll notice we have a region where x is less than or equal to -3. We have a region here in the center where my x values are greater than -3 or less than or equal to 4, as well as over here we've got x is greater than 4. So these constraints are dividing the graph into three separate domain regions. Let's look at graphing each one of these functions by making a table in each region. The first piece of my function here is that y equals x minus 1, and that occurs when my x value is less than or equal to -3. Now what we should do is we'll make a table of values, and we can plug in an x value as long as it is inside our domain. Now my domain includes -3, so I'm going to choose -3, and then I will choose values less than -3, maybe -4 or -5. Plugging -3 into my function, -3 minus 1 gives me -4. -4 minus 1 is -5, and then -5 minus 1 gives me -6. So I'm going to plot these points. And basically, they're all going to be solid dots, and we just have to consider what happens on the boundary at -3. And because there's an equal to, we can draw that with a solid dot. So we've got -3, -4, -4, -5, and -5, -6. This is my graph here. And we just want to make sure it's indicated that we can touch that boundary with a closed dot. My next piece here is that y equals -1. Y equals -1, and that is when my x values are between -3 and 4. So we don't necessarily need to make a table of values, but I'm going to choose my boundary values. -3, I'm going to choose one number in between them. You could choose more if you wanted, and then 4. And regardless of what my x is, this function tells me that the y value is always -1. So y equals -1 is a horizontal line at -1. We just need to look at what happens as we get close to that boundary on the left and the right. Now at -3, there's no equal to, so we cannot touch that. We would draw a nice big open circle. But at +4, we can touch that, so we'll make sure that that is solid on that endpoint. All right, let's deal with our third piece. The third piece I'm dealing with is y equals 1/2 x, and that is for any x value when x is greater than 4. So again, we'll make a table of values, x, y. I'm going to start with my boundary 4. Now, am I allowed to equal 4? The answer is no, so we know we're going to just draw this with an open dot at 4. And then I need to choose values that are greater, larger than 4. X is larger than 4. I can choose 5, but because I have this fraction with a denominator 2, I'm going to choose even numbers, so 6 and 8. So 1/2 of 4 is 2, 1/2 of 6 is 3, and 1/2 of 8 is 4. So I'm going to plot these points, 4 up 2, and making sure, since we know we can't touch this, that's an open dot there. 6 up 3, and 8 up 4. That gives us the rest of our piecewise function here. So this graph, what we're looking at right here, that's what you need to be able to create. If we start talking about domain and range, in this situation, what is the domain? So my x values, obviously we go off to the left forever, so we go to negative infinity. What happens? I get to -3, I can't touch, so this is still defined, we're still defined. And then here we have solid, open, still defined. So it's negative infinity to positive infinity. The range for this guy is a little bit tricky. Now remember, when we deal with range, we go least to greatest, and that's up and down. So we're going to start at the bottom and go up. My lowest y value is down here at negative infinity. And as we travel up, negative infinity, we have a gap where I'm not drawing my graph, right? There's a gap here between these points. So my high y value for this piece, that is at -4. So we've got negative infinity, -4, and we can touch that -4. Union, the next place we reach a defined y value is here at -1. And when we just want to include one value, we use curly braces. And then, of course, we continue traveling on our graph. It is not defined at +2, but it does continue going up forever. So this would be 2 with a parenthesis and then positive infinity. So if we wanted to think about domain and range on this graph, really getting into it, these would be our two answers. So I hope that helps you understand graphing piecewise functions more. You really have to break it down and do it piece by piece. No pun intended. All right, ask me, send me an email if you have any questions. I try to respond as quickly as I can. I am here to help. Have a great day.